An experiment that students ought to do in order to get across the idea that energy is required for a change in state is to melt ice by heating it using an alcohol burner or some other heating device. So what I've got here is an alcohol burner, a ring clamp, wire gauze, a beaker containing crushed ice, and then a glass rod for mixing the ice, stirring it, and a thermometer for recording the actual temperature. And then I've clamped it in place using a clamp to make sure that the beaker doesn't fall off during the activity. So we'll turn the heat on. Temperature right now is, as you might expect, 0 degrees Celsius. It's not a good idea to use a thermometer for stirring because a thermometer has a very delicate bulb which can easily break if students stir a little bit too vigorously. So the thermometer is just used to record the temperature, not to do the stirring. The temperature stays at 0 degrees. This is an important concept for students to know because during a change in state, the temperature actually stays constant. There is no temperature change. So while the ice is melting, as long as I don't heat it too rapidly, and as long as water and ice are both present, the temperature will stay very close to 0 degrees Celsius. And that's also an important reason why it's important to stir it before taking an actual temperature, because that ensures that the temperature is uniform throughout. So the temperature is just a little bit above 0 degrees Celsius. An interesting activity that students can do with this is to actually record the time and the temperature every 30 seconds, for example. So they can have it heating, and when they light the burner, that becomes in time 0. They record the temperature, and then every 30 seconds thereafter, they record the temperature again. And you'll find that even though heat is being applied, the temperature will stay at 0 degrees, or very close to that, until all of the ice has melted. The temperature is just above 0 degrees. Then you can do an interesting exercise. Have the students graph the results, with time along the x-axis and with temperature along the y-axis. And you'll get a graph that looks somewhat like the following. In the first while, the temperature will stay very close to 0 and then starts to go up once the ice is melted. So here we have water plus ice still present. And then once we get to this stage here, we get water only. So during this time, we're adding heat, but the heat does not result in a temperature change. The heat energy is used to convert the ice into water. We often refer to that as latent heat. The same process has to occur when we cool it down. When we cool it down, the heat has to be removed from the water, and that occurs at 0 degrees Celsius. It does not occur at 1 degree or at -1 degree. It occurs at 0 degrees. Just like the melting here occurs at 0 degrees Celsius, as long as we mix the mixture well. My temperature is just a little bit above 0 degrees yet. It's about 2 degrees now. And that's partly because I'm adding heat at a fairly rapid rate, and I hadn't been stirring it for a while. So it's important for students to continue stirring so that the temperature remains uniform throughout, and it's also important to use crushed ice so that there are no large chunks of ice in the beaker, which will take a long time to melt. So here they have an opportunity to do an exercise involving both measurements and then graphing the results.